Fisher projections are a way to represent three-dimensional configurations of chiral molecules in 2 dimensions without drawing wedges and trying to visualize stuff. So we've learned how to look at these. Here the dashed lines are coming out of the screen, and the dashed lines are going behind the screen. They're receding, and the solid ones are coming out at us. And so this gives us a way of looking at the configuration in 2 dimensions. But this can get very complicated when we get to larger molecules. And so Fisher projections are used a lot, especially when we get into talking about sugars and things like that. And so what's going on here is we draw the chiral center as the intersection between 2 perpendicular lines. And we put one group at the top and one group at the bottom, one at the right and one at the left. So we've got that chiral carbon, the stereogenic center here. It's got 4 things bonded to it. And the way you look at this is the way I remember it, is this is like a person. Okay, so here's a person standing here. And he's kind of arching his back away from you, and his hands are reaching out towards you to give you a big hug. Kind of awkward. But the horizontal lines are coming out, the vertical lines are going back. So he's bending back away from you, but his arms are coming out forward. Let's erase that. Strange purple person. So this is a flattened representation of this, where the vertical lines are receding behind the screen and the horizontal lines are coming out. Okay? Looking at this then, we've got, what are they trying to show us? They're trying to show us that if we kind of tip this around, that we can draw it like this. And then looking down this axis, we're looking to see, does this go to the right or to the left? I don't like that picture at all. If you take a Fisher projection and you switch any 2 of the groups, you make the opposite enantiomer. And that makes sense when you think about the horizontal ones. Let's do this. Just make a little space over here. If I keep, if I keep the top and bottom ones the same and switch the middle ones, do you see that that's the mirror image? Here's the mirror, right here. And so this one has the hydrogen on the right and the OH on the left. This one has the hydrogen on the left and the OH on the right. When we swap 2 of the groups, we change the chirality. How do we do the configuration? When we talk about an absolute configuration, we're talking about, is it R or S? First, prioritize the group, and then determine the sequence of the highest 3 groups. So we just learned how to do this. So this chlorine is going to be number 1. This is going to be 2, 3, and 4. So determining right or left, here we would like to have this lowest priority one in the down position, because that one is going away. That's behind. And so I can imagine if I'm sticking my thumb into the screen, the hydrogen is behind. And now, if I point my fingers towards number 1, can I curve my fingers? Do they bend from 1 to 2 to 3? Yes, they do, with my right hand. And so this is the right hand version. So this is the R configuration. if I draw the mirror image of that by swapping two of the groups, again, this is 1, 2, 3, and 4. Now this hydrogen at the bottom is receding behind the screen, so I can poke my thumb from the carbon to the hydrogen and stick my fingers to the chlorine straight up, and I can curve them from 1 to 2 to 3. I'm looking here at drawing a circle. I really like the hand thing, but I don't think it's really working for you guys. So 1 to 2 to 3. That's left, so that's S. And on this one, we're going 1 to 2 to 3. It's going clockwise. That's R. Okay? Any questions? Let me